First, let me give you some background about our company, Tailwind Traders, and we are a retail company. We sell online home appliances, gardening tools, accessories, and all kind of different things that you may need for your home. Customers can do the online shopping for all their home requirements. So our business is really growing fast, and we started with few sites and grown organically over the years. And we have acquired a lot of companies over the years, and from the financial perspective, we are doing a lot of transactions, and those are some of the inputs from the business perspective. Now, let me also give you some background about the technical perspective, especially around our application architecture. So, Tailwind Trader application is built on top of ASP.NET framework. The front-end components are running on the Windows machines, and the back-end components are connected to the SQL Server and MongoDBs. So SQL Server is running on the Windows machine and the MongoDB is running on the Linux machine. So that's a quick brief about the Tailwind Traders applications. In fact, we have been on-prem for a long time and it's been working well so far, and we have been very happy with the performance. So last week our leadership team and board of directors, they had a long meeting and they revived all aspects of the applications and the business projections, balance sheets, how we are operating at the on-premise, what is available in the cloud, and how are we doing the things, and so on. Also, they make some plans for our company to drive some digital transformation initiatives. So after a couple of days, an interesting thing came out of this meeting is that a little memo sent out to all our team from the leadership team. Basically, they are informing us that the New York data center, it's end of its lease, and they are not in a position to renew the data center contract. So our team have to find a way to migrate or move the workloads from the New York data center to some other data center or maybe public cloud. So that was a kind of surprise that we received last week. So they are changing everything. We have to move it. So we have to accept it and we have to live with it. Now it is also interesting for our team to learn the new things and move forward. Now let's see how our team is going to look at this now and what are the other challenges is going to follow. So initially we were evaluating to move the workload from New York data center to the other data center. Later we realized all our data centers are running out of capacity. So moving the workload from one data center to another data center may not solve the problem permanently. Even if we try to accommodate now, and very soon I'm sure we will get into another issues. So we decided to migrate the workload into the public cloud services. So moving to public cloud services, again, this is not very easy because this is not just grab your things and put it into the cloud. And there are a lot of careful planning exercises required in order to seamlessly migrate your workloads from the on-premise to the cloud, right? So let's see how our team have executed the planning exercise for this operations. When it comes to the migration planning, you should look at it in 4 aspects. So you should have a workload inventory, network inventory, storage inventory, and also you should have a clear understanding of the identity context. So let's see each items in details now. First, workload inventory. It is really important to collect the inventory of all your workloads which is running inside your data center. Also, you need to make sure that you have the stakeholder informations for each applications, so that in case if you have any issues or concerns related to that particular applications, you can reach out to them and you can keep the stakeholders informed and get the consent before you start any migration activities for the particular application. Now there is a study done by the Gartner says that 28% of the physical servers in the data center are ghost servers, which is often called as a zombie servers because they are still exist in the data center, but actually there is no use of those servers. So this is a great opportunity to identify such servers and have a backup of those VMs, and you can plan for retiring those VMs so that you can save the migration efforts. Finally, decide a migration strategy. How are you going to migrate? Is it going to be a workload migration, or is it going to be a lift and shift migration, or you are planning to rebuild something on the cloud? There are many migration approaches available, so you have to decide the right strategy for the particular application. So those are the key areas that we have gathered when it comes to the workload inventory. Now let us move on to the network inventory. So from the networking perspective, we have reviewed all the network documentations. We have gathered all the subnet details, IP addressing details, connectivity type from one side to another side, how this is connected with each other. Also from the DNS perspective, we have gathered all the internal, external DNS dependencies for each applications. From the connectivity perspective, we have evaluated how are we going to establish this connectivity to the Azure from the on-premise, what are the target IP schema, is it going to be the site-to-site VPN or is it going to be the express route? And also we have evaluated various other parameters such as what bandwidth we are going to receive when it comes to the site-to-site VPN and what VPN type we are going to use such as policy-based VPN or route-based VPN. So those are some of the key areas that we have paid a lot of attention when it comes to the networking inventory. So let's move on to the storage now. So from storage perspective, first we started mapping all the storage with our application workloads. For example, you know our website is a retail website and it has a collection of images which are part of the web content. For example, the pictures of hammers, pictures of dishwashers, which are part of the website. So we have to make sure that when we migrate our application to the Azure cloud, all the static data like images are properly being mapped to the website, right? So Tailwind Trader website is just one of the web application. Also, we have many line of business application. So we wanted to map the storage with all the workloads that we have. That was our key priority. So later we have also figured out from the storage sizing perspective. So what will be the required size in the target environment? Do we have any duplicates? Do we have any data which is no longer required? So when we did our auditing and reviews, we identified few hundreds of GB which is no longer required at all. So we decided to perform some cleanup operations at the source environment before the migration. So finally, we defined our security plans for the target environment. For example, is there any PII information, personal informations, or is there any credit card numbers part of the website? Is the data is being encrypted at rest? Is the data is being encrypted at the transit? So how are we going to manage the encryption keys? Is it meeting the local regulations when it comes to the data protections like GDPR regulations? So we evaluated all these aspects from the storage perspective. So let's move on to the identity space now. Identity is very important because we need to have a right identity strategy before we migrate the workloads. So there are several options that you could follow. Either you can use your on-premise domain controller extended into the cloud, or you can use the Azure Active Directory. In case if you don't want to maintain any on-premise Active Directory on the Azure, you can also use the managed domain, which is Azure Active Directory domain services. So let's quickly look at the pros and cons of each scenarios. So if you are using on-prem domain controller extended into the cloud, this is a great option as it supports a lot of functionalities such as group policy, LDAP, application partition, and so on. So in case if your company is completely modernized and you don't have any legacy domain controller dependencies, then you can still rely on the Azure Active Directory. This is most likely a scenario, only the scenarios if all your applications are cloud native and if you really don't have any dependencies with the on-premise domain controller, then this may be the right fit. The other final option is managed domains such as Azure Active Directory domain services. But again, Azure Active Directory domain services have a lot of limitations, especially when it comes to the multi-domain model. It doesn't support. It supports just a single domain, and one single domain is associated with the Azure Active Directory. You know that Tailwind Traders acquired a lot of companies, and if you look at our Tailwind Trader on-premise infrastructure, we have a multi-domain model. We have a multi-forest, multi-domain model. So this option may not be viable for the Tailwind traders. So we decided to go ahead with the domain controller running on the Azure, because the primary reason was some of our applications have a dependencies with the application partition. Especially if you look at our SQL Server, the SQL Server infrastructure are joined to the Active Directory domain, and it is heavily relying on the application partition, which is not supported by the Azure Active Directory domain services and also Azure Active Directory. And also we have a multi-domain model. So because of these two reasons, we have decided to go ahead with the on-premise directory extended into the Azure cloud. Now you know what needs to be done when it comes to the migration preparations, right? So the first step is to start the inventory process that covers from all aspects such as workload, network, storage, and identity. Now let us quickly go through some of the configurations from the planning perspective. Let's review our network configuration first. If you look at the on-premise network, we have an address space which is 10.0.0.0/22, which includes 4 subnets, which is NAT DMZ, Hyper-V LAN, Ghosted, and Production. And if you look at the Azure Virtual Network, we have an address space which is 10.10.0.0/16. And if you see here, the address space is different. Keep in mind that IP address space overlapping is not allowed in the Azure. So you need to identify the range which is not exist in the on-premise network. And if you see here, we have 2 subnets which is DMZ and Production, because the other 2 subnets which is not required, which is Hyper-V LAN and Ghosted subnet. We have 2 firewalls in the Azure. One is NSG, which is Network Security Group, and also we have an Azure firewall. The traffic is controlled by the NSG and Azure firewall. Azure firewall is the layer 7 firewall, which is primarily used in the gateway subnet, and the network security groups that you can apply on the virtual machines or subnet level. Let's quickly visualize the Tailwind Traders target network infrastructure. This is the Tailwind Trader target environment. You see here there are 2 subnets, which is DMZ and Production subnet. And also the traffic is controlled by the Azure firewall. So Azure firewall is a fully managed robust firewall available in the Azure. It's a layer 7 firewall, mainly used on the perimeter network to control all the incoming and outgoing traffic between the internet and the company infrastructure. So some of the key benefits of using the Azure firewall is that it supports the threat intelligence, it is highly scalable, it supports the FTDN tagging, and also it has a built-in monitoring and reporting capabilities. You can easily plug into the Azure Monitor, and also there are many other benefits it can provide. So between the subnet communications, you can use the network security group, which is the layer 4 firewall. So layer 4, it understands the source IP, destination IP, source port, destination port, and protocol. So using those principles, you can apply the network security group wherever required. So those are some of the key principles that you have to consider when it comes to the network planning. Now let us move on to the storage migration planning activities. From storage perspective, we have managed to clean up a lot of unused files, zombies VM, but still we see 75 terabyte of data that needs to be moved from the on-premise to the cloud. That's pretty big number. And unfortunately, not all our sites have the good bandwidth. What we have today is just about 100 Mbps at most locations. So if we wish to transfer the 75 terabytes of data over the internet through this 100 Mbps link, this is going to take roughly about 97 days. Because we have done a lot of calculations, so transferring 75 terabytes of data over the internet may not be the right choice for the Tailwind traders at the moment. So we need to find a way to migrate the data as quickly as possible. So what do we do now? Thanks to Azure Data Box service. Microsoft provides a service which is Azure Data Box. So using this service, you can initiate an offline data transfer. So we have decided to use the Azure Data Box service to migrate the data from the on-premise to the Azure environment. As I said earlier, we have done a lot of calculations around the online data transfer and the available bandwidth. So I am going to share some of my findings so that it will be useful when you make some planning exercise. So if you wish to transfer 10 terabytes of data and you have 100 Mbps link, then this is going to take 10 days for the data transfer. In case if you are having 1 Gbps link, then this is going to take 1 full day. Similarly, you can find the data quantity and the time taken for the data transfer closest to your workload size. That being said, let's quickly understand how Azure Data Box works and how to avail this service to migrate your data from your on-premise to the Azure infrastructure. Azure Data Box is an offline data transfer service which you can request from the Azure portal. When you are requesting Data Box, you need to choose the Data Box type, shipping information, and target storage account. So there are three types of Data Box available: Data Box Disk, Data Box, and Data Box Heavy. So the Data Box Disk supports up to 40 terabytes of data, and Data Box supports up to 100 terabytes of data, and Data Box Heavy supports up to 1 petabytes of data. In our case, we had to choose Data Box as our data size was roughly about 75 terabytes. So once you receive the Data Box device, you can plug into your network. So this appears as a SMB share. So then you can use the tools like Robocopy to transfer the data from your on-premise to the Data Box. So once the data copy operation is complete, you can ship the Data Box device back to the Azure Data Center. The team will map the Data Box into your storage account. So now the next question that comes to your mind that, wait, what if someone steal my data while it is in rest, right? So it's a valid question. So Data Box is encrypted at rest and you will own the encryption key. No one else can see your data because you are having the encryption key. So that being said, now you understand how Data Box works. Let's move on to the identity planning now. As I mentioned earlier, we have decided to place a domain controller within Azure due to the various dependencies that we had, like application partition, multi-domain support, and group policies. Also, domain controller serves the authentication request, so we need to make sure that this service is highly available. So we have decided to place a domain controller within availability set. And if you see here, look at the picture, there are two domain controllers placed, which is DC1 and DC2. So both domain controllers are placed under the availability set, which means in case any power failure or update failure that happens to the fault domain or update domain within the availability set will make sure that at least one machine is available within the data center. Also, you need to note that the domain controller running on the Azure must be considered as a separate site within your Active Directory environment. So we had to create the new site on the Active Directory and map the respective subnets into the Active Directory site so that any authentication request that comes from the devices which is in the cloud, that will be served by the domain controller which is in the cloud. In case if you do not specify the subnet configurations on the Active Directory site, then this is going to establish a cross-site communication which create unnecessary traffic across your network. So it is always recommended to have a right Active Directory subnet mapping configured on the Active Directory sites and services section. So those are some of the key things that we have considered when it comes to the identity planning. It's time for us to move to the demo. Let's see it in action how we used Azure Migrate tool to assess, plan, migrate the workload from on-premise to the Azure infrastructure. In this demo, we are going to migrate one of our internal applications. First, we will see how to use Azure Migrate tool to create an assessment for our environment. Then we will see how to gather the dependency mapping through the Azure Migration tool. Finally, we will see how to replicate the virtual machines and how to migrate the virtual machines from the on-premise to the Azure environment using the Azure Migration tool. Let's see it in the action now. So we have an internal application which is Mercury Health, which is used by all our employees. where employees can maintain the record of the physical activities, nutrition details, what they consume. Every activity can be recorded into this application just to have a better health life. Now, this application backend infrastructure is provided by the SQL Server, which is running on the Windows machine. So let's quickly look at the Mercury SQL database and the associated tables. Now, assume that you wish to migrate this application, but you really don't know what are the other dependencies, such as how many servers are connecting to this SQL server. And this is very important because when you are migrating some workload from on-premise to the Azure, you need to make sure that all associated servers also getting migrated. So this is why you need to have a clear dependency mapping. Let's see how Azure Migrate is going to provide the dependency mapping. Let's create an Azure migration project and discover our environment. So there are several options available. In our case, our workloads are running on the Hyper-V environment. So I am going to select discover, assess and migrate the server options. In case if you wish to migrate just database, you can go for the other options as well. I am going to create a migration project. Let's go through this wizard. First, you need to provide the subscription details, resource group details, and then provide the migration project name and the location. Then you can select the migration assessment tool. Here you can find various tools available for the migration, this including the tools from the ISVs. ISVs are nothing but independent software vendors. Azure Migrate Server Assessment is a Microsoft tool which is free for 180 days. So this tool will help you to perform the assessment. Also, it can be a migration tool as well. So I am going to choose Azure Migrate Server Migration tool for this operation. However, you can evaluate various products in terms of pricing, functionalities on all those aspects and decide the right tool for your migration. From the pricing perspective, you can always visit Azure Pricing Calculator to get more details about the pricing. Let's select these tools and move forward. Let's add these tools into the migration project. So now the Azure Migrate environment is created. The first step is to do the necessary discovery procedures. So let's click on the discovery and provide more details about our virtualization environment. So in this case, Tailwind traders are using Hyper-V platform. So I'm going to choose the Hyper-V. So now you need to download the Azure Migrate virtual appliance. This is nothing but a virtual machine where Azure Migrate components are installed. You need to have this machine running on your Hyper-V platform so that it can fetch the necessary dependencies details from your application. You see here Azure Migrate Appliance Configuration Manager is already pre-configured. So let's click on the Azure Migrate Configuration Manager and go through the further configurations. We are now setting up the discovery for the Azure appliance. Let's accept the license term. It further checks the connectivity to the internet, time sync settings and so on. So we have already registered the Azure Migrate environment some time back. So let's register this appliance into the Azure Migrate. So this is going to ask Azure credential. So let us provide the credential and complete the authentication process. So after the authentication is complete, the system will allow us to register this Azure Migrate appliance with the Azure. So let's choose the subscription details, Azure migration project's name and appliance name and register the appliance. Now I see the appliance is successfully registered. The next step is to provide the Hyper-V host details. So let's provide the credentials so that Azure Migrate can fetch the necessary information from the Hyper-V host. I'm providing the Hyper-V host details, which is hyper-v host.twt.local. So then validate. The validation process takes a while. Once the validation is complete, we are good to start the discovery procedures. So the discovery procedures may take time, depends on the number of Hyper-V hosts you have, the number of VMs you have. So in this case, we have pre-captured this clip. So let's take a look at the discovered servers. And you see here under the dependencies, it requires an agent. So keep in mind that Azure Migrate is an agentless migration tool. However, this agent is required in order to gather the dependency details and capture the server performance, so that it will help you to understand the dependencies for your applications. Also, the performance details will help you to size the target infrastructure. So let's proceed with the agent installation. So this will ask us to configure the OMS workspace. So the OMS workspace is a legacy name. Now this is called as a log analytics workspace. So you can choose the name and the location. And once the OMS workspace is created, now you need to install the Microsoft monitoring agent and the dependency agent on all the machines. When you install the Microsoft monitoring agent, you need to provide the workspace ID and the workspace key, so that the agents can collect all the necessary information from the virtual machines and report it back to the log analytics workspace, where you can see the dependencies. So now let us go back to the discovered server and see if the dependencies are updated. Now I see here the dependencies have been updated. Also note that I have not installed the agent on the Azure Migrate appliance because I am not going to migrate this one. Let's assess our environment now. So the assessment operation is going to assess your on-premise environment and share the recommendations for the migrations. So let's provide the assessment name and provide the target parameters such as target location, storage type. You can choose your right location because the price is determined based on the location. I don't have any reserved instance, so I'm not going to select this. So from the sizing perspective, here you can provide the VM sizing criteria, let's say performance based, which means this is going to assess your on-premise performance. Based on that, this is going to provide the recommendations. So this is not a good idea to run the assessment tool during the weekend. It is always better to run it for a week so that you can get the right sizing guidance from the Azure Migrate tool. So this is very much self-explanatory. You can choose the VM series, pricing options, pay-as-you-go model. Also, you can choose your currency. Also, if you are eligible for the hybrid benefits, you can say yes. If not, you can say no. So now you have an option to group this assessment. In case if you have hundreds of servers, then you can have a separate assessment report for each applications. Then you can select the appropriate servers. So in this case, I'm going to select all the servers that are related to the Mercury application. So let's validate these configurations and move forward towards the assessment report. So this operation takes some time. Now the assessment is being computed. Slowly the Microsoft monitoring agent and the dependencies agents will start passing the informations back to the log analytics workspace. So you can refresh here and see if the information is updated. Generally it takes a couple of minutes. Also note that in the real production scenarios, the assessment needs to be run at least for a week time so that you will have a clear understanding of your application functionality in terms of the performance and the dependencies. For example, your application may initiate some web job maybe once in a week, which is triggered by some unknown server. So if you just run this assessment for a day, then you may not be able to get the exact dependencies. So it is recommended to run this assessment at least for a week, so you will have a complete picture of your applications. Let's refresh this assessment, and you see here the groups and the assessment gets updated. I see here groups and assessment gets updated. Now let's click on the assessment report and see what's inside. Here you can view the dependencies, and the dependency mapping is getting populated, and it is fetching the last 1 hour data because we just triggered the assessment report. And you see here there is a SQL server, there is a Linux server, there is a Windows server. So, and also this is providing various other details such as the network communication, how the one server and the another server is communicating with each other, what are the ports it is communicating, right? So this is called the dependency mapping. So this information is really important when it comes to the workload migration, so that you can have a clear plan when you are migrating your SQL server. You know that, okay, there are other two dependencies which is associated with this SQL server. So it will help you to make a right planning when it comes to the migration planning. So that's all about the dependencies. Now let us look at the assessment report. So this is the assessment report that is generated by the system. And I see here there are 3 machines which is ready for migration. You can also find the estimated monthly cost, including the breakup, such as what will be the compute cost, what will be the storage cost, and so on. So now if you look at the VM size, the recommended sizes for the SQL Server is standard DS1 V2, and the recommended size for the IaaS, which is standard F4S, and recommended size for the Red Hat Linux machine, which is standard F4S. This is great, right? So Azure Migrate tool is able to provide the recommendation for these servers based on the performance data collected by the Microsoft monitoring agent. Now we have got the discovery completed. We have also got the assessment report completed. So now the next step is to perform the migration activities. If you recollect, when we set up the migration project, we selected 2 tools. One is for assessment and second one is for the migration. So now the next step is to migrate the service. So to migrate the service from the on-premise to the Azure, again we need to perform the another discovery from the migration perspective. I'm going to provide input here. My virtual machines are running on the Hyper-V and I'm going to choose my target location. So let's create this resource, and this is going to take a while. I see this is complete now. So now it is time for us to prepare a Hyper-V host server. So we need to install the Azure Site Recovery Provider executable on the hypervisor. So once you complete the installation, you will be able to see the Hyper-V host, and that completes the registration process. So during the installation, you will be asked to provide the key file details. So you need to download the registration key file as well from here. So that contains the encryption keys and the IDs of the recovery services vault. So I have already downloaded the Azure Site Recovery Provider installer and the Azure key file. So both are located in the Hyper-V host. Now let us go back to the Hyper-V host and install the provider. I'm going to install the Azure Site Recovery Provider now. The both files are located in the desktop. So this is going to ask the vault settings, and let's locate the key file and complete the registration process. And this is going to take a while, and then very shortly the registration process will be completed. The wizard is creating the certificates, setting up the Azure Site Recovery for registration. And I see the registration is complete now. Now let us go back to the Azure portal and see if the Hyper-V host details are updated on the Azure Migrate tool. Let us rediscover and see if the Hyper-V host is updated here. Let us redo the process here. I'm going to choose virtualization as a Hyper-V, and I'm going to choose the location. I see Hyper-V host is updated here. So let's finalize this registration process, and this is going to take a while. Shortly this will be completed. Once the registration is complete, now we are ready to replicate the virtual machines. So let's go back to the Azure Migrate page and refresh and see if this is discovered in its service. So under the migration tools, you see some machines will be displayed as part of the discovery process. Let's refresh this page. This is going to take a while, and shortly this will be completed. And I see there are 4 servers displayed as a discovered service. So let's click on the discovered service and see the options for the replication. I see here 4 server names. In case if you wish to group it, you can definitely group it. In our case, all 3 machines will go at one shot. Let's replicate these machines, and let's select the source settings first. So our virtualization platform is a Hyper-V, so I'm choosing my Hyper-V. On the Virtual machine settings, you have an option to apply the migration settings. Let's use our assessment report. So let's select the assessment groups, let's select the assessment, and finally you can choose the machines that you wanted to replicate. So now let's select the target settings. In the target settings, basically you have to select the region, subscription, resource group, and the target storage account and virtual network where you wanted to deploy this machine. Let's select all the details. Let me select the virtual network and the subnet. This is going to be the production machine, so I'm choose the production. In case if you wish to apply the hybrid benefit, you can apply here. Let's provide the compute options. In the compute options, you see here, this is the recommendation that is given by the Azure Migrate. But if you wish to change the compute option, you can definitely do it from this wizard. So let's choose the target operating system. Let's choose the disk configuration and make sure that everything is correct. Here you can select the disk. Let's start the replication. Yes, now the replication is getting started. The replication is definitely going to take significant amount of time based on your data and based on your available bandwidth. So once the replication is complete, you see the status showing as protected, and make sure that the replication status is healthy. So in our case, all the 3 machines are fully protected, which means it is 100% replicated. Now I wanted to test the migration just to make sure that everything is working as expected. So let's perform the test migration. You can find all the target configurations and settings for the specific virtual machines from Azure Migrate tool. So I'm going to activate the test migration for all 3 virtual machines. So let's provide the virtual network and submit the test migration. So let's do it for the other 2 machines, which is IaaS and the RHEL. Just providing the virtual network and submit the migration. So the advantages of the performing the test migration is that your source machine will not be turned off. So you have an opportunity to test your workloads and various functionalities without affecting your production workloads. Let us go back to the Azure Migrate page and refresh and look at the test migration status. And if you notice here in the test migration status, now the migration is in progress and very shortly this will be completed. And I see this is completed now. Now let us go back to the resource group and look at the resources, how this is installed on the Azure resource group. I'm going back to my Azure resource group. Let me look at the dashboard and select the particular resource group. And let us filter by the virtual machines so that we will just see the virtual machines. And I see here there are 3 machines which is ending with -test. So those are the 3 machines that are activated by the Azure Migrate as part of the test failover procedures. Okay, now the test failover is complete. Now what do we do next? You need to log into all your application server and make sure that they works as expected. So you need to perform the test cases. So once you are happy with the test results, you can perform the cleanup procedures so that the machine will be removed from the resource groups. To perform the cleanup, click on the perform more test migrations and let's go through the configuration. Let's select the machines and this is going to take few seconds and you can evaluate all the configurations. Click on the cleanup test migration. And let's do the same process for all the machines. And this is going to remove all the machines from the resource group. Now let's do it for the IaaS. Let's go to the IaaS and let's clean up the machine. Cleanup test. And let us do it for the RHEL as well. So we have cleaned up the test migration resources. So let's do the production migration. To do the real migration, you can go to the step 3 on the Azure Migrate tool. So here you can activate all the machines at one shot. Also, you have an option to turn off the source machine. It's really up to the environment. So since this is my first test machine, I am leaving this as is. So once I perform the post migration activities such as changing my internal or external DNS dependencies, or validating the application front and back end connections, later point I may decide to turn off the source machines. Now this operation is going to take several minutes, and let's wait until this completes. By the way, as a best practice, you should have a migration runbook where you can capture all the details about the application, such as configuration details, application owner details, and also the test plans that you can document it, so that post migration you can make sure that you have all the information and you can perform the necessary testing. And I see now this is complete. Now let us go back to the resource group and let's look at the resources, how this is named. So this time I don't see any dash test, so which means the machines have been successfully migrated. So let us go back to the database server and have a look at the DB configurations. So let's connect to the database engine, and keep in mind that this time the IP is different. Let's make sure that the SQL Server have the Mercury Health database and its associated tables. I see all the informations are correctly migrated. So that's bring to an end of this demo. Let's quickly look at some of the best practices that you could follow to optimize your resources on the cloud. You can always leverage Azure Advisor recommendation that's going to give you the advice based on cost, performance, and security aspects. So you can continuously optimize your workloads. You can take the recommendations from the Azure Advisor and continue to optimize your cloud workloads. Also, don't forget to leverage the built-in intelligence services that could definitely help you to meet your governance, security, monitoring, resiliency, and automation requirements. Also make use of cloud adoption frameworks where you can find our best practices, reference architectures, migration patterns, and so on. So let's quickly summarize what we have learned today. In the first module, we discussed about migrating your workloads from Windows Server 2008 to the Windows Server 2019 infrastructure. Later, we have discussed about leveraging the hybrid cloud benefits using the Windows Admin Center. Finally, we have learned about how easily you can migrate your on-premise infrastructure as a service workload to Azure Cloud using the Azure Migrate tools. That being said, I like to leave a closing note that migrating your workload from on-premise to the Azure infrastructure will definitely open up a new door for the innovation and accelerate your digital transformation journey.